Hi! In this tutorial, Tutorial 5, Section 5, I will again be expanding upon the original button and object experiment program by adding new code to set some of the properties of the various program elements. This final tutorial using the button experiment program demonstrates a few more GAMBAS program object principles, along with using some additional programming, IDE, and GAMBAS elements. Additionally, in this program exercise, we will be using the GAMBAS IDE menu editor for the first time to add a simple menu to the existing program. So let's get started. First, open the existing Button and Object Experiment 1A program project within GAMBAS. Do this by starting GAMBAS. Choose Recent Projects and then select Button Experiment 1A, or alternately, you can choose Open Project and navigate to the project in your program's directory. We now want to continue modifying the program, again without necessarily changing the earlier working versions. So, once the Button Experiment 1A project is within the IDE, select the File menu and choose Save Project As. Enter Button Experiment 1B as the new project name. Select your program's directory and click Save. Once you have saved the new project, check that GAMBAS now shows Button Experiment 1B in the top of the IDE. Again, this has created a new project with a different name, which will allow you to bring up the original unchanged projects should you run into problems or want to try something else. Remember, I really recommend that this always be the first thing you do while experimenting and learning. Now that there is a new copy of the Button Experiment program to work on, we are going to modify the latest version of the program with some new code and a little more manipulation of the various program objects' properties. We will also be adding some new program elements. The last time the Button Experiment program was modified, we added an image to Button 1 and set the text property of the associated label control. Now, to make the button actually do something, we will add a single line of code to the Button 1 click event. At this time, use the now familiar message command to display a text message when the control is clicked by a user. Double-click on Button 1. And in the code block which starts with public sub button 1 click, add the code message open paren quote mark GAMBAS programming rules quote mark close paren. This is just a trivial bit of code to make Button 1 do something, now that the button has been effectively modified to act as a clickable UI graphic element. Remember, this program only exists to be a learning experience, so feel free to alter it, add things, and create new versions to experiment upon. Now I am going to use Button 2 to change the form's background color at runtime. First, click on Button 2 and change the text property to the word color. You can also resize and center the button at this time. Next, we are going to add a little bit of very simple code which will effectively cycle the form's background color through various shades of blue. At this point, I would like to state that this next example is a very crude bit of code. Commonly, this type of code is called a kludge and does a job in a very inefficient, sloppy way. But for the current purpose, the program code is very simple and works. Don't worry, I do intend to cover the fundamentals of computer and GAMBAS color principles and functions in far greater detail in later tutorials. But for now, double-click the color button, button 2. And under Public Sub Button 2 click, enter the code fmain.background equals fmain.background plus 15. This will increment the form's background color variable value by 15 each time the user clicks the button. This has the effect of causing the form's background color to cycle from dark blue through lighter blues and then restart at the darkest color. It will recycle through this sequence over and over again. Again, this code does the job for this level, but this method is intended only as an extremely simple way of demonstrating continuously changing the form's background color without utilizing language elements that I haven't covered yet. To see what is actually going on while the program is running, under the first line of code in the button 2 click event, you can add the line print fmain.background. Then save the project and run the program within the IDE so that you can see the messages that are output to the console at the bottom of the IDE while the program is running. The values stored in the fmain.background property will be displayed each time you click button 2. You will see that the value simply keeps incrementing by 15, although fmain's background will appear to keep cycling through a small set of various blues. This is due to the way that computers and GAMBAS actually specify on-screen colors. Remember, this is just a very quick and dirty way to crudely manipulate this color property at runtime, without my needing to layer on too much additional information at this point. Again, I would like to stress that this code example is really not the correct way to specify or control program screen colors. This is due to the fact that this method does not correctly manipulate the multiple numerical values that are actually used internally by GAMBAS to control the color property. Basically, this method of changing the form's background color actually relies on a mathematical quirk of the numerical methods used by computers and GAMBAS for specifying the colors that are being displayed. Another reason why you shouldn't use this method to set color properties in GAMBAS is that if a user is really dedicated and just keeps clicking button 2, eventually they will exceed the color property variable's maximum value and get a runtime error. But you don't really need to worry about that problem in this example, since it would literally take thousands of clicks within a single run of this program to create that particular error situation. Hence the reason at this programming level it is adequate for this simple program example. However, I would like to stress that creating a program meant for actual use, in which a user simply by using the program as designed can cause an error or a program crash, is a really poor coding practice. But again, don't worry, in future projects I will explain in greater detail how colors are stored and correctly manipulated within computers and GAMBAS. And I will describe with examples how to properly set object colors in GAMBAS programs. Now, back to the example program. You may have noticed how hard it is to see the label's text once the form's background color is set to a shade of blue. A quick fix is to set the label's background color to a persistent and more useful, better contrasting color. Right now, the label's background color property is set to default, which means that the label's background color is the same as the container within which the label is placed. This works fine as long as the form's background color provides a good contrast. In the original example, black letters on a gray background. However, now that we are changing the form's base color to a very dark background, we need to override the label's background color to be a more useful static color. To do this, within the IDE, again select all of the labels. Select the first label and hold down the Control key and select the other labels. Once they are all selected, in the field next to the background property, select the three dots to bring up the color selection dialog box and select the background option. This will effectively lock the label background color to the initial default gray color regardless of what new color the form's background color is set to at runtime. Please note, this is simply an arbitrary color choice by me. You can set the label background color to whatever you choose, as long as the text is easily readable by a user. Remember, simplicity and ease of use are usually the best user interface design principles. You can go ahead and resize and recenter the labels to better align the labels now that their background is going to be more obvious to a user. Additionally, in order to see the current color value of the form's background property without needing to run the program within the IDE, we can add a new line of code to a couple of points in the program's class file so that the information will be updated on the program's title bar as the program is running. Since the fmain form's text property controls what is displayed in the program's title bar, we can update the title bar to display the current value each time the color is set or changed. Here is the code that we will be adding to display the form's background property information on the form's title bar. This code sets fmain's text property, which is what is displayed in the form's title bar. The equal sign or assignment operator tells the program to set fmain's text property to the string of characters on the right-hand side of the equal sign. Here is the actual text which will be shown in the title bar. I chose this exact string of characters and spaces to look balanced and uncluttered while the program is running. I tried different text strings until it appeared the way I thought it looked best. But it is basically an arbitrary aesthetic choice and can be changed and formatted to appear however you want it to appear. The ampersand or and character is used in GAMBAS to concatenate or build strings from smaller collections of characters. In this case, the actual value stored in the background property variable is being added to the end of the descriptive text string. You should note, the form's background property is actually a numerical value. However, the GAMBAS language will automatically format the data into the correct variable format in order to display it as a text string. So this intimidating looking bit of code is actually very simple in concept. It breaks down into setting the form's title bar equal to a string of text plus the current value in the form's background property. I will include this line of code in the description below the video, so you can copy and paste it into the button experiment program if you wish. But feel free to try typing the code in manually and changing it to suit you. The first time the color is set is when the fmain form opens. So click on the fmain class file and scroll down to the section that begins Public Subform Open. Now, within the Form Open code block, under the me.center command, enter the new code fmain.text equals button experiment 1b space space bg-color space equals space ampersand fmain.background. This will initially set the title bar to display the form's background color information when the program first launches. Next, under the code section Public Sub Button to Click, directly under the code fmain.background equals fmain.background plus 15, replace the print program line with the same line of title bar code. Again enter fmain.text equals button experiment 1b space space bg-color space equals space ampersand fmain.background. Since this code is identical in both locations, you can copy and paste this line of code from above. Now, each time the user clicks the color button, the program's title bar will be updated to display the latest color information. Again, go ahead and save the project. At this point in the experimental program, I decided to include the ability to be able to reset the form's background color to its initial state while the program is running. To do this in code at runtime, we will first use an event connected to the fmain form. Since in object-oriented programming, objects have events that trigger code execution, we will need to use a valid event from the form object's internal class. There are two ways to add such an event to your code. The first method is to manually enter, i.e. type in, a new valid event subroutine into the program's class file. However, this requires a somewhat more thorough knowledge of the events available within the object's class file, which is a little beyond these first tutorials. Luckily, there is a simpler method in GAMBAS. All of the available events for any particular object can be accessed within the IDE. To access the list of events for an object, right-click and continue holding down the mouse button while over the object, in this case the form. Move over the pop-up context menu to the event selection and release the right mouse button. Then in the event pop-up context menu, select the event which you want to trigger the program code. Here we want the double-click event, so left-click on the double-click option. This will add the necessary subroutine code block to the program's class file and place your cursor within that event's code block. Once the form's double-click event has been accessed, thereby adding the appropriate code block to the project's class file, add the code fmain.background equals -1. In this case, the default background color value is a light gray. It is actually represented by the numerical value -1, so setting the form's background color property to -1 effectively resets the form to its original light gray background color. Don't forget, since the background color information is changed, under the new code to change the form's background color, again add the code to update the title bar. And again, you can just copy and paste the code rather than retyping it. Now when the user double-clicks somewhere in the program form at runtime, the form's background will be reset to gray and the information in the title bar will be updated or synchronized with the program's actual background color state. Go ahead and save the project. Now we should go ahead and test the program so far. Run the program in the IDE. With the program up, repeatedly click the Color button to cycle through the background colors. Notice that the form's title bar updates whenever the form's background color is changed. When you are through changing the form's background color, double-click on the form's background to reset the form's background color to the default gray. Again, notice the form's title bar after the background color is reset. Go ahead and exit the program. Here is another programming tip. While we have just added a theoretically useful feature which allows the user to easily reset the form's background color, generally when you write programs for others, it is considered to be a best practice to make all available actions and functions within a program somehow visibly accessible to the user. While double-clicking on the form to reset its background color is known to us, the ones that implemented the code, it probably won't be intuitively obvious to someone else. Shortcuts are great and are really appreciated by regular users of a program, but most users do not want to have to ask a program guru in order to learn of a program's hidden features or have to consult documentation simply to know that a useful feature exists. So now we are also going to add a very simple menu to our program using the menu editor. This will allow a user to access a couple of useful program actions. Creating menu objects creates menu events within the form's class file. Menu events behave just like object events, except that the program functions can be seen by the user and chosen off of a list of options. The advantages are that anyone familiar with computers can navigate and more easily find program functionality without having to become familiar with a specific program's user interface. In other words, they don't have to hunt around and learn the design of a specific program in order to find and use its functionality. Also, by moving the functionality to a menu, less of the program's options have to be directly integrated into the program's visual user interface, meaning cleaner and simpler designs. Honestly, entire books have been written on effective program design, and there are many schools of thought on the subject. Not to mention the fact that user interfaces are continually evolving, and no one really knows exactly what the next great user interface trend might be. So other than a general recommendation for clean design, simplicity, usability, and reliability, I leave the creativity to you. For now, I'm going to create a very simple menu system for the program. This is going to be a quick example of creating menus, and I am just going to walk through accomplishing some basics at this time. But in the next program example, the tab program exercise in tutorial 5.6, I will be exploring the menu editor in greater depth. In the meantime, again, feel free to use the following information to experiment with creating menus in your own programming experiments. Now, to create a menu on our program's form, select the main form. And with the title bar of the form visible in the IDE, click the Menu Editor Quick button on the editing toolbar. Don't forget, you can also choose the menu editor from the IDE's Edit menu while the form is displayed in the IDE's work area. The menu editor is where menu objects are created. Here is the menu editor in which a single menu entry has been placed to show some of the fundamental elements of the menu editor. There are three areas of the menu editor that we are going to use at this time. First is the main menu editor toolbar located in the upper left. This is where menu entries are created and various quick buttons are used to organize the menu entries. This toolbar contains quick buttons to insert a new menu entry, insert a separator, delete a menu entry, indent and unindent menu entries, and also to move menu entries up and down in the list of menu entries within the menu editing window. Next is the menu editing window. This is where the basic menu elements and the layout of the menus are shown, while a menu system is being created. And last is the menu item property window. This section of the menu editor allows the programmer to set the various internal properties of the individual menu items. Functionally, the menu editor creates menu elements that exist as additional program objects within a program, and those menu elements have a click event associated with them. So within the program's class file, menu click events exist as code blocks in which programming code is placed. That code executes when a user selects that menu choice. Within the menu editor, we are going to use the Insert Quick button on the menu editor toolbar to create two primary drop-down menus on the menu bar. These root menus are the menus that the user sees on the program's menu bar while the program is running. The two menus that we will create are a menu designated Control with two submenu options and a menu designated Help with one submenu option. So we will be adding 5 menu entries in total. Within the menu editor, click the Menu Editor Insert button 5 times to enter 5 individual menu entries. You will notice in the Editor Property window that each menu entry as it is created is automatically given a unique name by GAMBAS. Once again, this is due to the fact that every program object within a GAMBAS program must have a unique name to identify it, and the GAMBAS IDE assists the programmer by creating a unique object name each time a new object is added to a program, incrementing the names numerically when multiple identical objects are added. Shortly, we will be renaming these objects. We are going to change the menu objects' names to make it easier to identify the event code blocks within the program's class file. This will make it easier to place program code within the correct locations by making them easier to identify. But we must follow the basic rule that every object in a program must have a unique identifying name. The GAMBAS IDE generally enforces this for us and will not allow a programmer to create multiple objects with the same name. We are also going to change the caption property for each menu item at this time to create the actual text of the menu choices that are displayed to the user. First, click on Menu 1. And in the Property window, change the name property to Menu_Control and change the caption property to Control-Menu. Next, click on Menu 2, and in the Property window, change the name property to Menu_Reset_Color, and change the caption property to Reset Background-Color. Then click on Menu 3. And in the Property window, change the name property to Menu_Quit and change the caption property to Quit. Next, click on Menu 4. And in the Property window, change the name property to Menu_About and change the caption property to About. And finally, click on Menu 5, and in the Property window, change the name property to Menu_Version, and also change the caption property to the word Version followed by 3 periods. While the text of the menu choices, which is displayed to the user, are mostly a matter of personal design and specific functionality, the actual object names used within the source code should be somewhat consistent, so that creating, updating, and understanding the actual program source code is as simple as possible. Again, there are different accepted conventions for naming and identifying program and source code objects. But the primary concern in your own experimental projects should generally be a consistency that facilitates ease of coding and readability. There are also commonly accepted practices and general layouts associated with the menus themselves that most computer users have come to expect. For example, programs will commonly have File, Edit, View, Tools, and Help menus, and users have learned to expect certain functionality within those menus. However, those are all topics of some debate amongst programmers, so I will discuss some of those conventions when I cover menus in greater detail. For now, I am just covering the fundamental mechanics of creating a menu system within a GAMBAS program. Now we need to move the various submenus under the correct top level or root menus. This is done within the menu editor by indenting the submenus. Put simply, if a menu entry is not indented, then it is considered to be a top-level menu and is displayed on the program's menu bar. If a menu item is indented, it is considered to be a sub-menu item of the unindented menu item above it. So we have 2 top-level menu items, the Control menu and the About menu. Under the Control menu, there will be 2 items, the Reset Color option and the Quit option. Click on the Reset Background Color menu item, and once it is selected, click the Indent Quick button on the Menu Editor toolbar. This will indent the menu item, placing it as a menu choice within the Control menu. Next, click on the Quit menu option, and again, click the Indent Quick button to also place it within the Control menu. Finally, under the About menu element, click on the Version menu option and click the Indent Quick button to move the Version option under the About menu option. You can close the menu editor by clicking the OK button. You will now see that the F-main form has a menu bar with the new menu options that we just created. Also, if you click on a menu on the menu bar, you can see the submenus as options under those top level menus. Now we are going to do one last bit of polishing on the layout of the first drop-down menu. We are going to put a separator in the Control submenu to visually separate the two Program Control submenu choices. Go ahead and relaunch the menu editor. Click on the Version menu option, the last entry in the menu editing window's list of menu elements. Click the Insert Separator Quick button on the menu editor toolbar. This will put a separation bar at the bottom of the list of menu elements in the menu editor window. You will also note that the menu editor has named this element Menu 1. That is due to the fact that that particular menu item identity is again a unique and available identifying name for menu objects. With the separator highlighted, click the Move Up Quick button on the menu editor toolbar to move the separator up. Keep clicking the Up Quick button on the menu editor toolbar until the separator is between the Reset Color option and the Quit option. Once the separator is in the correct location, use the Editor Property window to change the name property of the separator bar to Separator 1. We are not going to use this menu object as an actual program code object. However, by giving it a descriptive name, we will be able to more easily identify it and we can avoid possible future confusion. Finally, close the menu editor. That completes creating the menu system for the Button Experiment program. Go ahead and save the project and run it to see the menu system. Now that the menu objects have been created and are visible on the program's form, program code can be placed in the program's class file. This code will be executed when a user clicks on a menu choice. Within the IDE, to add code to the first menu item, click on the Control menu Root menu on the form and click on the Reset Background Color submenu. This will create a menu reset color click event within the program's class file and place the cursor within the new code block. You should notice that the menu object's event name is rather consistent in structure and easy to locate within the source code. This is due to the specific structure of the name of the object that was employed when the object was created in the menu editor. In this example, each of the menu item code blocks will begin with the word menu and include the menu item's functionality, making the class file easier to search and modify. Generally, such intentional consistency and simplicity within source code tends to greatly simplify coding endeavors, and I really recommend it. Now, here within the Reset Color menu event, the code needs to set the form's background color to -1, and this code block also needs to update the form's title bar since the program form's background color is being changed. Since we have already done this within this program, simply copy and paste the lines of code from the other event in the program's class file. Here is another programming tip. Normally, when you realize that you are repeating code within the same program, you should consider creating a single instance of the code and placing it in a subroutine which is callable by different sections of the program whenever that specific functionality is needed. This reduces code redundancy and improves efficiency. Subroutines and how to use them will be part of the upcoming GAMBAS modules section. But for now, in this simple programming example, these redundancies are harmless to the general efficiency of the program and allow the functionality to be more easily understood. Now, bring up the form in the IDE's work area, and again click on the Control menu, and this time click on the Quit menu option. Once the cursor is in the new Menu Quit Click event, type in the GAMBAS basic command, quit. And finally, bring up the form in the IDE's work area one more time and click on the About menu option. Then click the Version menu option. In the Menu Version Click event, enter a message command to display version information in a pop-up message box. Enter the code message open paren double quote version space 1.2 double quote close paren. In this case, I have somewhat arbitrarily decided to call this version 1.2 to reflect that the first version, version 1.0, was the original button experiment program when it was first created. Then version 1.1 represented the changes that were made in the second button experiment tutorial. And lastly, these will be the latest modifications of the program. Therefore, I am calling it version 1.2. This should be the final iteration of this experimental program within the tutorial series. We are now going to make some final minor aesthetic program changes, and then after the experimental program is complete, we will compile the completed button experiment program. First, within the IDE, select all 4 buttons on the form. Again, do this by clicking on the first button, holding down the Control key and clicking on the other button controls. Next, in the Object Properties pane, click in the field next to the mouse property. A drop-down arrow option will appear in the field, allowing the programmer to choose which mouse pointer is displayed when the mouse is moved over the program buttons at runtime. Click the down arrow in the mouse field. Choose the Pointing option to set the mouse pointer to the hand pointer for all of the selected button objects. Now, when a user moves the mouse over the buttons within the program, the mouse pointer will change to the pointing hand to indicate that they can click on something to trigger a program action. Go ahead and run the program and see the results. And remember, it never hurts to frequently click the Save Quick button on the editing toolbar once a change to the program has been successfully accomplished. While we are polishing the final appearance of the program, we can better center the text within the label's background text area. This is useful visually when the label's background color is a different color than the container within which the label is placed. The right margin can be easily set simply by resizing the overall width of the label. However, the leftmost starting point of the text by default is nearly at the leftmost vertical edge of the label, which may not produce the best visual appearance. There are two ways to easily change this. The first method would be to simply add spaces at the beginning of the text within the label's text property, and then to align and resize the label for the best appearance. The other method makes use of the label's padding property. Padding determines if there is any space between the start of the control's visual area and any element placed within that control. Both methods work, however both methods will still require a little trial and error to get the precise appearance which is desired. So when tweaking the label appearance, adjust the left margin using spaces or padding. Next, adjust the width property as needed, and then finally center the label. You can run the program in the IDE to test your adjustments while you are making them. When you are satisfied with the appearance, save the project. And finally, once you are through making changes to the project, you should compile the program into an executable. You can either open the project menu and choose Make and Executable, or you can click on the Make Executable Quick button on the project toolbar. Then enter a new program name and destination for the new program file, and click OK. Close GAMBAS and run the new program. In the next tutorial, Tutorial 5.6, we will be creating a program using a tab container object. Within this tab container, we will be placing numerous graphical controls to get a feel for the many different types of graphical elements that are available within the GAMBAS programming environment. We will then use a little program code to control and send data between those program objects to see how more complex and unified graphical programs can be created. Again, thanks for taking a look at these videos and joining me as I explore the GAMBAS language and making these videos. I hope you find them useful.